Two carts of equal mass are on a horizontal surface with negligible friction. Cart A is approaching cart B, which is at rest, as shown in figure 1 above. Attached to cart B is a spring that is initially compressed. At the moment cart A collides with cart B, the spring is released and pushes on cart A, as shown in figure 2 above. Which of the following correctly states what happens to the kinetic energy and the momentum of the two-cart system as a result of the collision compared to those quantities before the collision? Okay. So we have two concepts here, two main concepts. One of them is the general conservation of energy in the system. We are not adding or taking out any energy. There's no friction. There's no air resistance. So there's no energy, and there's no external forces being applied. So, well, there are external. There's the weight of the objects and their normal forces, but it is a frictionless surface, so we don't need to think about that. So we have conservation of energy, which would be a sum of the kinetic energy plus the potential energy. Our gravitational potential energy is 0, but we do have a spring potential energy. So there's no math to be done here. We have, let me show you the diagram here. So, the second concept that comes into play here is momentum, once again, linear momentum. So since there is no energy being added or extracted from the system, the momentum must be conserved. So we can go ahead and cross off answers A, which says that the momentum decreases. We can cross off C and D, which both say that it increases. So that leaves us with B and E, which both say that it stays the same. So now we need to figure out whether the kinetic energy increases or stays the same. So we have, initially, we have the kinetic energy of, well, let's write out the sum of the energy. So we have the kinetic energy, E kinetic, plus the potential energy, E potential, and it's from a spring, so I'm just going to put POT spring. And that is 1, and 1 is equal to E kinetic 2 plus E POT spring 2. So when we have, so there, this is the main concept, is that the initial energy of the initial kinetic energy of the system plus the initial potential energy stored in the spring must equal the sum of the kinetic energy and potential energy in the spring after the collision. So with a spring, the potential energy of a spring is defined as 1/2 kx squared, where k is equal to the spring constant, which is a property of the spring. So that is either something that you know, or something that you will have to figure out when you know other things, such as the displacement x with a certain force applied. But right now, all we need to know is that the spring force is equal to 1/2 kx squared, which means if x is the displacement of the spring from rest, so if we have a spring here, this is a spring not stretched and not compressed. If we compress it, that will give it a positive or a negative x value depending on how you set your axes, but it's really the magnitude of that value that matters because it is squared for the energy, making it positive anyway. Or if you stretch it out, it will also have potential energy caused that is greater for the greater x. So, since we know that in this system, in figure 1, the spring is initially compressed, we know that it has a positive, non-zero positive potential energy stored in the spring. And as soon as the cart labeled A bumps into it, that spring is released and extends out and causes the boxes to move away from each other. B was initially at rest, it's moving away from block A afterwards. A is initially at rest, A is not initially at rest. A is moving towards B, and then it moves in the opposite direction. And at the end of it, the spring will be back at 0 because it will have released all of its potential energy. And since we are not losing any energy in this system, that potential energy has to go somewhere, and the only place it can go is to the kinetic energy. So that tells us that since the potential spring energy is 0 in the second one, or after the collision happens, that means that the kinetic energy increases, as shown here, because all of the potential spring energy is released in the form of kinetic energy.